I'd like to welcome you to the Tools for Identity session. We have 3 excellent speakers lined up for you. I'm going to save the announcements. I'm going to scatter them out throughout the whole session because I think you've heard a few of them before already. I'd like to start with our first talk. And this one is on connecting research collaborators to applications using co-manage. This was originally scheduled to be presented by Scott Corrinder from the University of Wisconsin. However, he has been replaced by his 2 worthy collaborators, Heather Flanagan and Ben Oshrin from Spherical Cow Group.
So this will be a certain amount of slide deck karaoke because as Scott was not able to be here, I get to present his slides for him. And Scott and I have different presentation styles, so it should be a little challenging on this one, but I think we can manage it. I have to ask this question. How many people have heard of co-manage? Good, I love it. Thank you. It warms my heart. So I do want to thank Scott for these slides and also thank Chris Whalen, who is in the International Program Office of Cyber Infrastructure and Computational Biology at the NIH. For those of you who have heard of co-manage, you will have heard us talk about the physicists that we work with. Earlier this week, you'll have heard Jayant talk about their deployment. Well, this is a deployment that's being sent out by the United States National Institute of Health, as they've got some very interesting virtual organizations spread around the world that definitely need the kind of help that co-manage can provide. So the Office of Cyber Infrastructure and Computational Biology is part of the National Institute of Allergy and Infectious Diseases. As an aside, having a meeting with these people when you're surrounded by the tuberculosis studies over here and the malaria studies over there, it's a little intimidating. But they work with researchers around the world to understand more about these diseases and try and figure out how to help cure them or prevent them or whatever's needed. They do have, this isn't an NREN, right? But they do have IT support that they offer these research groups. They have consulting that they offer these research groups. And they've been doing this for quite a number of years. So what kind of things have they noticed regarding what do virtual organizations actually need? Of course, they need the core services of a network. Given the distributed nature of the research, the network is critical to them. The collaboration, nothing happens anymore at any single institution, no matter where it is in the world. They've found a lot of explosion in the data types that they need to actually support. And they have these clearinghouse centers of where the research does tend to focus. All of this is, over the last 20 years, seriously been changing the face of how research happens in the world. So we talk about the core network services. Folks all know what those are. All of you are familiar with what networks are. And these are, of course, fundamental, the things that the network has to have. But one thing has come up. People have said, well, what about, I'll get to that one. This is the sort of global nature of what we're talking about. What about using cloud services? What kind of applications do these groups really need outside of the usual wikis and mailing lists and whatnot? Well, when it comes to health research, they need a lot, and it's not a lot that we normally see in sort of the high-level collaborations that we as NRENs often manage. Of course, they've got text, but it's text that's very sensitive in terms of the privacy that they have to preserve. They've got genetic information and the large data sets that go with genetic research. They've got medical images, which can take up a significant amount of space and bandwidth to transfer. High-performance computing. They've got to be able to audit all of this to know who's seeing what information and what actually is being shared. So they've talked about, okay, well, there's all these tools in the cloud I hate that term, cloud, that exist to help out hospital researchers and whatnot. Some we already know, like the Dropbox, the Googles in the world, the Skypes, the basic collaborations. But there's more out there that they have to worry about and use. But one of the problems that all of these share is how they handle identity in groups, because every application that they need wants to handle it in its own special way. Give you a for instance right now where, and we'll get to this later in the slide, we're working with them on how to have SharePoint consume information from a co-managed registry, which is in turn consuming information from organizations around the world, and it's hard. SharePoint was designed to be in an enterprise with, you know, the model of you're either in the enterprise or you are out of the enterprise. It's not this broadly diverse thing that we're trying to make it make it become. So yeah, every cloud service, almost every application has its own database, its own group information, and the sheer management of accounts is, of course, now this is a theme we've heard a lot. Managing all of these accounts across all of these applications is non-trivial and not really what they want to be doing, because account management has nothing to do with solving for malaria, for instance. Now, of course, there is the whole single sign-on. Why don't you just use your Facebook identifier or your Google identifier? These conversations we've had them as we've talked among ourselves. It's why we've created identity federations. It's why we're in this room, really. But some of these other groups, like the NIH and their VOs that they work with around the world, they're rediscovering what we have already known, that yeah, that's great that you've got a Facebook account and a Google account and whatnot, but that's not what you want to use for your science. So they've started to, the NIH group has started to try and join trust federations to get past this social identity area. And they've got the problems that we've heard from physicists, that we've heard from, you know, in a way it's now becoming, it doesn't matter what sector you're in, you're going to have the similar problems of what if you're researchers, and this is pretty common in, say, Africa or Asia, you've got a researcher who's critical, but they're not part of any identity federation. So joining the different federations is only so useful. They're going to keep trying because there's no other reasonable option for them. And in the particular use case we're talking about here, they're using 2 international centers for excellence, we call them ICERs, as the base use case for, okay, well, let's see if we can't truly make this work in the manner that we want. If we can make this collaboration work using Identity Federation, using the variety of tools, using a collaboration management platform, can we actually make it happen? So they're doing the usual things. It's a SAML-based attribute world. They are having the same problems of attribute release, even though you know, we have the research and scholarship bundle, getting that released enough, and including for these groups that, well, they're not exactly part of their federation. They're sort of being shoved in under the covers, but it's not a graceful fit. Getting the attributes for them to make the collaboration work continues to be something of a challenge. So this is sort of as we talked about this, where we are the co-managed team and the folks at the NIH, we said, all right, well, what's this big picture? What's the architecture that we're looking at? We're looking at different universities, we're looking at sponsors, we're looking at nonprofits, and they're all trying to support these centers for excellence. What does that mean they're going to have? Don't know if you can see the circle at the bottom, but what it shows you is, you know, SHIB IDPs, SHIB SPs, LDAP, an attribute authority. All these things are stuff that we've said, all right, this is what we're targeting. This is what we have to build in. Now, I don't know how many of you were in a session earlier this week where they talked about some of the challenges in South Africa where they were trying to get EduRoam to work. In the African VOs, they do have some really, really challenging infrastructure to get through, because the attribute release problems aside and the joining identity federation problems aside, they've got problems with actually having power consistently running in their data centers, much less cooling for their data centers, much less the internet access staying stable. You know, they're doing some advanced science in an environment that's simply not, it's not conducive to it, certainly not from an IT infrastructure sense. Bandwidth is low, the interruptions are constant. It's a heck of a situation. So, keeping that in mind, as we were designing the infrastructure for this, there's a lot of local redundancy built in, because you can't assume that your local sites will be able to actually talk to any central like metadata service or any other IDPs, or actually talk to anything within the Federation to get more information that they might need. You can't count on that. You can't count on the access to a central LDAP directory if you wanted to have a common collaboration platform. So designing in that redundancy. For the applications themselves, it's similar. The SharePoints, which will be the core of the collaboration piece, because it has that calendar and the wiki and other such things, there's going to have to be several copies of that. Mailing lists, similar, replicate that across the different VOs. And there are various auditing tools which they have to have. So, good, it's a little darker on that screen than it is on this screen. From here, we said, so we went through all of that discussion with the VOs and said, wow, you've got a really interesting environment. And then we said, let's figure out, we can't fix your power problem, but maybe we can keep it in mind, design around it, and let's talk about at least what your identity problem looks like and what that life cycle ought to be. And with that, I will transition to Ben, who can talk about this in more detail, and then talk about how we actually are working with them to deploy co-manage to support all of this interesting stuff.
All right, so I'll talk a little bit about the technical architecture, and more interestingly about some of the concerns that go into the collaboration platform deployment. For the sake of time, I'm going to keep this fairly high level. There's a little bit more detail in the slides which are available for download, or we can have questions afterwards or during the break for some of the more details. So what's a collaboration management platform? For terminology definition, collection of applications, identity services to support a collaboration. Co-manage is one such collaboration management platform, but there are several even just represented here at the conference. Co-manage specifically was funded out of an NSF grant in the US for 3 years. The co-managed domain covers a number of topics that we're all, I think most people in this audience are pretty familiar with. The leveraging of federated and social identity to provide access to services, onboarding and offboarding workflows, and then critically attribute and group management for the final item of provisioning and application integration, because ultimately nobody really cares about the identity aspects. What they really want is access to their applications. Co-manage itself is an open sourced, internationally aware product, but it's just one piece of an overall architecture. Obligatory screenshot. There'll be more. So here's the overall architecture for the co-managed deployment for the NIAID program. You'll notice there's kind of these divisions of lines going, and this is something of a geographic distribution. So on the bottom left, we've got services that are deployed at the Mali site. On the bottom right, we've got services that are going to be deployed on the Uganda site. And then across the top, we've got kind of the common services that are presented across the network. And there's too much detail on the slide to get into right now, but what this gets at is what Heather was mentioning, which is the sites in Mali and Uganda have some problems that maybe we have or maybe we don't have in our typical university data centers. When the power goes out, the servers are down. when the network uplink goes out, there's no connectivity to the master servers. So what we do here is put the critical but not time-critical servers up top. Effectively, you can think of those as the primaries or the masters in a standard kind of replicated environment. So for example, the co-managed registry is up there, but the registry isn't really 24/7 operationally critical. If the registry goes down, it's okay if it takes a little bit of time to come back up because applications aren't hitting it directly. What they're hitting are attribute authorities, LDAP servers, shibboleth IDPs, and of course the applications themselves. And so that's what you see replicated at the sites, with the master data provided, actually in this case, hosted at AWS. Besides the technical challenges of the architecture, we also have a variety of business process challenges. And again, I think some of these will sound pretty familiar from other contexts. So the classic example of the researcher with multiple identities. I started at University A, I migrated to University B, but I'm still involved in the same project. I still need to be seen as the same individual. And there are variations on this where you're multiply enrolled or you want to use social identities, et cetera. In this case, we're using co-manage to create VO-specific identities. That's effectively the person's identity for the VO. We maintain a specific set of attributes for application access, et cetera. The applications don't use your EPPN, whichever one it may be. Instead, co-manage creates and manages a VO-specific identifier, and this is a screenshot of an example configuration for one, which co-manage automatically assigns. We then use, basically when you authenticate into an application, we do a look-aside query to find out what specific identifier that EPPN maps to, and that's what the application actually ends up keying on. So you end up with something that looks a little bit like this, where the service is mapping from EPPN to a VO-specific identifier via the SAML attribute authority. Another problem is that IDPs don't release name or email, which is perhaps something that becomes a little bit better over time with things like RNS bundles, but to date, we're even just within in common only about a quarter of the way there in terms of IDPs that support RNS. This is really Scott's rant, so I'm just going to accelerate the presentation a little bit. Our solution here is to basically overlay attributes using co-manage. So as part of your enrollment process into the VO, we collect the additional attributes that we're not getting from your IDP. Beyond that, co-manage maintains the ability to collect and maintain attributes from the IDP. So if, for example, we do get your name and email address out of the IDP, we don't need to collect it separately as part of enrollment, and subsequently, if they change, then co-manage will get the updated attributes as well. There's, of course, the question of whose attributes are authoritative. If you come from two different universities, that's a question for another time. This is an example of the set of attributes that might be collected as part of an enrollment process. And you can see it goes a little bit beyond what RNS would grant. We can also collect things like affiliations and telephone numbers and validity dates. And the bottom two there are actually %FT is an extended attribute that's not even part of the core data model. So you can add additional attributes as necessary for your use cases. For the sake of time, this is basically the same idea where actually, well, to dwell on this for a little bit. So in addition to the one unique key, applications often have their own identifiers that they need. You can think of this in terms of migrating legacy applications. Let's say you've got a Confluence installation where everybody already self-signed up with certain usernames, but those aren't the usernames that people are authenticating with in a federated context. Well, with co-manage, you can track those identifiers and map across them, so when somebody logs into Confluence, they get the Confluence-specific identifier. Similar use cases you can imagine involve Unix applications, SSH logins. In this case, the Slipstream appliance mentioned here is a domain-specific environment, basically a Unix server with a bunch of applications running on it, where effectively we'll use the same technique to manage SSH keys, allowing access into that service. You can end up with customized identifiers such as this, or just mapped back into whatever your legacy identifiers were. Here's an example of a person's record in CoManage. And so you can see from the top, we've got a primary and preferred name. That's the name as known to the VO. That's not necessarily the name that the university asserted if they have a university identity. We've got a couple of identifiers below that, an EPPN, but also the CoManage specific identifier, the email address that the person wants to use for the collaboration, some group memberships, some status, role attributes. You can see this one has a validity of 5 days. I think perhaps an optimistic engagement in terms of the amount of time somebody might be, oh, I'm sorry, it's 3 years and 5 days. That makes more sense. And then finally, this person uploaded a set of SSH keys for CoManage to distribute out. I mentioned already the low bandwidth and lack of reliability of the connections. I think this is basically just a zoomed in picture that's easier to see of the architecture designed to handle that. Some services integrate with one IDP only. I'm sure nobody here is familiar with this problem. And so the solution there is the IDP SP bridge, which we're building into the solution for the NIAID deployment. And of course, the IDP won't release anything, let alone a name. We can't even get a global identifier. Well, what do we do about that? You'll notice the social cloud in this diagram, and if nothing else, we've got the bypass option, right, which is you can use a Google identity. The collaboration management platform will track that along with any university identities you may have, and we can use that as your unique identifier. We also have IDP of last resort as a solution in that space as well. Ultimately, at the end of the day, if your university IDP is not releasing attributes, there's not much we can do short of getting them to release attributes. I think for the sake of time, we can skip the wrap-up slide and just jump straight to the acknowledgments and thank a number of people, including Michael Tartakovsky, the CIO of NIAID, Jeff Erickson, the manager for identity management at the NIH, Ann West, Tom Scavo, John Krenke, and the other usual suspects from In Common, Ken Klingenstein, and Matthew Economou, who is also another one of the technical folks involved in this deployment. With that, I'm not sure how we are on time.
You're good.
Okay. So thank you. Questions for either of us?
All the way back there. Okay.
Of course, it's me. When you have the unique identifier in CoManage, is it a derivative? And you're essentially doing an account mapping exercise across those applications. And how do you track the applications? Is it by like the entity ID? Can you just expand upon that, please?
Sure. So the identifier can get assigned in a number of ways. There's no particular restrictions on how that would happen. So typical environments would be either a random number, sequential number, string prefixes, so on and so forth. Or you can do it manually or come up with some custom algorithm for doing it. This is, so I guess there's maybe it's good to think about it in terms of the platform identifier and then application-specific legacy identifiers. So the platform identifier is intended to solve the multiple EPPN problem. Ideally, you just assign one of those per person via whichever algorithm you want, and then as you integrate applications, you just map to that one identifier, so you don't necessarily need to do them on a per SP basis. We do that mapping at the SP. So in that context, we do that mapping at the SHIB SP typically. The application-specific identifiers for when that doesn't fit your use case. So typically that would be I've got a bunch of legacy applications that already have usernames, or I've got applications that for some reason don't handle the format. Maybe they can't handle identifiers that are that wide or have a specific letter in them or something. In those cases, there's kind of two pieces. One is assigning a label to it on the platform side, on the CoManage side, so that you know which identifier it is. For example, a GitHub identifier, perhaps. That'd be a case where you can't actually force your identifier into, so cloud applications are a good example of that, where you can't force your identifier into the SP, so you track their identifier instead. And then, again, we do the mapping on the SP side, so the SP knows what The SP software knows what SP service it's in front of, and it can just query for the correct identifier at login time.
Okay. I have a second question, but if there's others, I'll wait.
Go ahead.
So the second question is about how many instances of the co-managed platform would you deploy in a given federation? I can see how one large science project would want or desire control over a co-managed instance, but what's your opinion on whether or not a federation should operate a single instance of co-managed and have that that feature and function centralized?
Right. It's complicated. So
that's why you would only have one, right?
So, well, no, the answer is complicated. The software, of course, is also complicated. So the way I would look at that is co-manage the software is multi-tenant, right? You can set up one instance that hosts multiple VOs. But then you get into the usual question of trade-offs. So depending on the complexity of the integration needs for a given VO, that might be fine. If you're a small VO and you just need some file storage, a wiki space, maybe one or two easy to integrate apps that can query an LDAP server, then one multi-tenant instance operated at the federation level can support that use case. As your needs become more complicated and you need to do custom provisioning, or you've got really complicated enrollment processes that require custom coding solutions, anything that doesn't work in just the drop-in hosted environment, that's when it probably makes sense to start thinking about having independent deployments.
Okay, thanks.
Any other questions? Oh, right. Oh.
If I remember correctly, it was mentioned during the presentation that users prefer not to use their social identities to access work-related resources, right? But still, you seem to have a social gateway, right? And do you have any numbers or experiences with that, if this is really not used at all by users? Or?
It depends. In some cases, it's up to the VO itself. Do they want to trust social identity or not? So we've got one use case, not with this group, but with another one, where they've said, well, we'll allow social identity, but if you come in with a social identity, you can only get to this subset of things. You need a vetted identity to actually get to this other set of things. So we'll see a different balance depending on what exactly they need. The point of the co-managed platform was to be flexible enough to allow all things based on what was going on in the virtual organization.
Also, I think to channel Scott a little bit with his LIGO hat on, they offered for, I forget which applications, an option to either self-register for a LIGO guest identity or to use your existing Google identity for access to whatever low LOA services they were providing access to. And I believe it was somewhere between 0 and 2 people went for the social identity option. Almost everybody picked the LIGO guest identity option.
It's a brand new moment.
Okay, let's thank the speakers again, please.
I can hide.
Our next speaker you might recognize. I apparently am not driving this. There we go. So the next speaker is Ben Oshrin again, and he's going to tell us about Cipher APIs, filling the gaps in the exchange of identity data. Also, still from the Spherical Cow group.
And now for something completely different. So a little bit of background in history. So back, and I looked at this slide this morning and I thought, has this really been 5 years? And then I went to go find some gin. So 5 years ago, there was an A-camp, and for those of you who aren't familiar, A-camp is the advanced camp. It's basically where a bunch of identity leading edge thinkers and other crazy people get together and have an unconference, and there'll be one at the Internet 2 Technology Exchange in October this fall. But this one was the 2010 one in Raleigh, which might actually have been one of the first ones. And a bunch of people sat in the room, and the timing of this was, it was just after Oracle bought Sun. And we all started thinking, this is terrible. We're all running Sun products. What's going to happen now? So a bunch of us started thinking about this, and we're like, well, you know, we look at the open source identity management software stack, and there are some good products out there at the time. You know, SHIB was well along, CAS was out there. In the non-higher ed space, there was, you know, few LDAP servers, et cetera. Grouper, I think, was in the process of getting more widely deployed at that time. But there were certain things that weren't there. And we thought, well, we should come up with some approach to help fix this problem. And so we didn't know what to call it. So originally we called it OSS IDM 4HE, open source software identity. I don't even remember at this point. Something like that. And we thought it was a terrible name, so some time passed and we came up with Pfeiffer, which in retrospect was also a terrible name. The Free Identity Framework for Education and Research. So one of the things that was identified as part of this, in addition to the usual, well, where's our open source product X and Y, was the need for APIs as a way to provide standardized communication across the entirety of the identity management space. At this point, we had LDAP and we had a few other standards, but going across the board, there were some missing gaps. So we said, well, you know, let's tack API onto the name, and we'll do this Pfeiffer API thing, and we'll try to put some thought into this and see what we can do. So some time passed, and the next year, ACAMP was co-located with, at the time it was called JSIG, the JSIG conference. And for those of you who aren't familiar, JSIG was responsible for uPortal and CAS and a couple of other projects at the time. And so some folks from JSIG, some folks from Kuali, which does higher ed open source enterprise systems, and from some folks from Internet 2 sat around in a table in a room that I think was called the library and said, you know what, we should really solve this. So, you know, we had a good dinner, put some thought into it, and we came up with some new names. So we lost an S, lowercase to D, and then we thought about the name some more, and finally came up with Cipher, which was the Community Identity Framework for Education and Research. We didn't just work on names during this entire period, but for historical purposes, that's kind of where I'm going. And then we still thought this API concept was a good one to be working on, so we changed the F to a C, and we thought, we'll work on these Cipher APIs now instead of these Pfeiffer APIs. Time passed, and we even got a logo. But then change started to happen. Kuali disappeared from the meetings and conversations. JSIG became Apereo, and we were kind of left with this logo and some participation primarily out of the Internet 2 community at that point. This animation, we had some slide issues. There was supposed to be an animation in here, so never mind. Anyway, over time, the Cipher work, other than the API stuff, kind of faded into a stalled state. Since then, Tier's come along and looks pretty promising as an approach to address this problem. But we've still got the Cipher API thing hanging out here, or just it's not dead yet. So what is it, now that I've gone through the entire history of naming? So the Cipher APIs attempt to make some sense out of this messy picture. This is one representation of the components that you'd see in a typical identity management context, especially in a university or other complex organization. Starting on the left, we've got systems of record and data input sources. By the way, this is an old picture, so it's kind of hard to read, and the colors are a little nauseating, but just bear with me. Then we've got an integration layer, which is APIs and user interfaces and messaging. And then we get to some core identity management services, identity match, identity registry, provisioning and integration, directory, groups and authorization, credential stores and SSO. And then we've got some outbound integration, which looks like the same as the inbound side. And then identity consumers, because again, at the end of the day, nobody cares about identity management. They want access to the applications. The bits here that are in red, which are the thick lines or the dashed lines, were the pieces that we identified at the time as gaps, things that we needed to work on. And you'll notice that in the arrows, which is effectively where APIs would show up, there's an awful lot of gaps there. There are a handful of things that are solid black lines. So, for example, into the directory and out, that's LDAP. That's a pretty well-known protocol at this point. Around SSO, we can talk about SAML and so on. But there's a lot more not there than there is there. So we came up with the Cypher APIs as an attempt to facilitate loosely coupling your identity management deployments. So part of the problem that we were trying to avoid was vendor lock-in, where you go buy the big stack of software, then, I don't know, the company gets bought out, and you're stuck with this thing that you now have to either scramble to maintain or pay some license fees that went up 20 or 30 times. We thought that by developing APIs, you can, instead of having a big monolithic solution, have a small component-oriented solution. So maybe you have to tear out component A, but you don't have to tear out your entire suite. As we looked across the space, I think you probably can guess where this slide goes. Certain things turned out to be okay, right? We've got directory APIs, we've got authentication, we've even kind of got provisioning APIs to the extent that people use them. There are some significant gaps. So the SOR to registry API is for if you've got a scenario where data is authoritative at, say, your student system or your employee system and then migrates to an identity registry. That's what the SOR to registry API is intended to get at. Identity match is another common one. So if you come from an institution with multiple authoritative sources, you've got your student system, your employee system, your alumni system, your guest system, you need to be able to match records across those authoritative sources so that you don't issue duplicate identities. The ID match API is a way of standardizing the request to a back-end solution to do the match. It doesn't do the match for you, it just standardizes the way that the request is made. And then account management, things like creating accounts downstream or doing password expiration policies or validating second factor authentication, registration, that kind of thing. So now that we've kind of got the domain, we start looking at what's out there. And of course, the first question that we keep asking ourselves over and over and over again is, why aren't we just using Skim? If you'd like to stay here for 2 years, I can recite the entire conversation that we had around this. But to summarize, it's a close match for certain use cases, but for some use cases, it's just not close enough. So for example, in the identity match space, we're not just searching based on attributes. We need to be able to convey different types of fuzzy matches and other potential resolutions. We need to be able to convey matches for administrator review. There are different ways that an identity match service can be implemented, whether it's coordinated or independent, and a bunch of other details that don't fit on the slide. So that pushed us away from Skim for a while. As did some elements of the schema. So some of this is massageable and some of it isn't, but as we dug into the schema, certain attributes didn't map exactly how we needed them to map, and adding additional sub-attributes to Skim is possible, but makes things turn out weird, and so on and so forth. So there's a whole set of these things. Some of them are more easily solved than others. We can certainly follow up on some of these details offline. But in the end, we thought, this is starting to look like a mess and a bit of a headache. Then the pendulum swings back the other way, and we think, well, why not use Skim? There's no need to reinvent the wheel. We don't need another definition for how to do pagination. They've already got search filters. We don't need to come up with new definitions for every query parameter that you might pass or response codes. And then we've got versioning to think about, which is a mess. So there's the reference for our analysis. But as you can see, it's not quite a clear-cut decision. So finally, at last year's ACamp, exhausted from all of this Skim versus not Skim conversations, we thought, let's just make a decision. And so the proposal we came up with was that we would use Skim as a basis for the Cypher APIs, but embrace and extend it, I guess, as we go along. So for example, we'll adopt things around pagination and search queries and so on and so forth, but we're going to come up with effectively a replacement schema. So, a way to think of that is we're going to start with Skim API, but not with Skim core schema. And there are a few diffs we need to do from the API, but it's not terrible. So the core schema itself came from an analysis that we did across a number of existing products and concepts in the space. So we looked at the time, a number of open source identity management projects, including the registry products, Open Registry and CPR out of Penn State. We looked at CoManage and KIM. KIM is the Quali identity management software. We looked at various standards and protocols that existed, EduPerson, which we all know and love, but some other things as well, including OpenSocial and some other higher ed specific schema definitions. And we came up with a mapping of the sorts of things we needed to actually define, but we realized that's still not going to cover every use case, so we still need to allow provisions for locally defined attributes. The core schema comes with things that you expect, right? So person-level attributes like address and gender and photo and name and telephone number. Where we start to run into some problems, not necessarily problems, but where we start to fork off from SCIM pretty quickly is at the role level. We tend to attach a much more detail to a role than SCIM does by default. Again, not incompatible, just one more thing on the road to consider. But again, these attributes all look, and these aren't exhaustive lists, by the way, but these all look, I think, pretty familiar if you've been working in this space. You know, titles, display title, because of course your display title is different than your professional title. Termination information, leave dates, validity dates, percent time, sponsors, and so on and so forth. And it's all, you know, JSON-y stuff, right? We've all seen JSON a gazillion times. So here you can see a couple of examples of the types of problems we were looking at. Everybody has a net ID and everybody has an internal system-to-system identifier, but how do you label them? Well, so okay, we've got a network identifier and an enterprise identifier. We've got the multiple names problem, so names is a list. We've got language encodings as well as types on the names, because if you've got a campus in the US and a campus in China, you need to be able to track the representation of the name in both Chinese and Roman characters. And then we've got some more complex role information, again, truncated to fit on a slide. With the core schema, then, we can start talking about the different types of APIs we can build, including, for example, the SOR to registry API. So as I started to say before, this is an API intended to say you've got a student or an employee system like Banner or PeopleSoft or any of a number of other commercial vendor products, or even the Quali suite. Let's have a single way of conveying attributes from that into your identity system, whatever your identity system happens to be, and with a recognition that for quite a while, people will still be running custom code. Right? You may be looking at open source products, but if you've already gotten your Perl scripts from 15 years ago and they're running, maybe they'll run for another 10 years before you need to do something with them. That said, building an API that adheres to a standard like this solves the transition problem to some degree. There's no reason you can't put an API like this in front of your, well, there shouldn't be a reason you can't put stuff like this in front of your Perl scripts, although I guess it depends on your Perl scripts. The concept here is that a system of record can only ever be authoritative for a role, not for a person. If I come from a student system and I come from an HR system, neither is authoritative for me as a person, just my student role or my HR role. Ultimately, it's the identity registry that maintains the canonical view of the person. There are varying types of integration patterns here, and so the concept in the APIs is to support the common ones. There are systems where the systems of record operate independently. The HR system has no idea what's going on in the student system. And then there are those that are coordinated. This is sort of a master data management yes or no kind of question. And so the API allows passing attributes in both fashions. And again, these are stripped down for slide purposes. In the left-hand column, the HR system is passing just person-level attributes. In the right-hand side, it's passing role attributes as a separate transaction. In this case, it's basically the same data being conveyed, but it's just coming in as a role transaction. Beyond that, you've got the typical questions around updating and deleting. If you've seen one RESTful API, you've seen them all. So that's SOR to registry. The ID match API looks similar but serves a different purpose. So ultimately, this is trying to solve the problem of, do I already know this person that's being asserted by a system of record? Again, as with the previous API, a system of record can only assert knowledge about its own population, but the goal here this time is to obtain what's called a reference identifier, which is basically just a unique identifier is known to the match service for a given purpose, for a given person, sorry. A typical flow for an identity match can happen like this. Again, kind of hard to read, but there are two different paths here, basically, which is whether or not the systems of record are directly integrated with the identity match service, or whether it's hidden behind an identity registry or an equivalent person repository, and whether or not they're coordinated or independent, whether or not they agree on, what master data elements are. I won't walk through all of this, but it's in the slide deck that you can download, or we can talk about it in more detail offline. Obligatory copy and paste out of the browser. So this is an example of an identity match request going across to an identity match server. We've got a URL that gets cut off in the top, but you can see we're passing a bundle of matching attributes. In this case, we have a name, we have a date of birth, and we have a national identifier. It's a fake identifier, so no worries there. And coming back, we get a status code of 201 created, which means this is a new person, not previously known to the matching service. And we allocated an enterprise-wide identifier of 50015. There are a few other responses that can come back. A 200 means I already know about this person, and here's the identifier you're looking for. A 202 means human intervention is required. I couldn't find a canonical identity for this person. There are too many J. Smiths in the world, or Pat Lees. So here's a request identifier for you to come back to later, but we're handing this off to a human to go look at. And then the 300 response is the scenario where the calling system is capable of looking at that and making a response. That's mostly where the calling human is in front of a web page making a request and is able to then and there pick a candidate out of the responses. Beyond that, there are a few other ID match API operations that we need to support for administrative purposes. So you can imagine that if you've got an administrator, they want to see what pending matches haven't been resolved. You want to be able to force a pending match to resolve. And then a little bit more unintuitively, after the match is done, if the person's name changes, let's say they get married or otherwise change their name, you need to tell the match engine about that, or else it will match against the wrong name if they come back and reaffiliate later. So that's the match API. Another API we're looking at is the Registry Extraction Api. We love the name, but it's probably not a good name. And really, this is just a provisioning API at the end of the day. It's about getting data out of the registry and pushing it somewhere for downstream systems. That could be into an LDAP service, that could be onto a message bus, that could be directly into applications. That one only gets 2 slides because it's not very far along at the moment. And that kind of takes us to an overview of where the various APIs are at. As you can see, there's not an API, there's several, and so they have different levels of maturity. Some of them are implementable and actually have been implemented at least at a proof of concept level or at a single site, but none of this stuff has been finalized yet. We're still kind of evolving the documentation and the use cases and so on and so forth. Our goal now is to get sort of tentative drafts of documentation in place for the October TechX. Hopefully that will happen. Of the various APIs that we've been talking about, this kind of points out where the design maturity is at. So at the top of the list, there's the ID match API, where there's actually a BSD licensed server available on GitHub that I would not use for production purposes, but is certainly useful for testing and purposes. That's actually available for use. The core schema is getting closer and closer to a stabilization point, and then from there it kind of drops off. SOR to registry, I think we understand what needs to go in there, but I'm not sure we've exercised it enough as a concept to really have a good solid foundation for the draft, for a draft document, although we're getting closer. And then from there on down to authorization, registry extraction, and account management. And of course, authorization, there are multiple APIs in that space to choose from, so it may be that the correct answer for Cypher API in authorization is to say, go use one of these other existing things that's out there already. And then finally, just the list of pointers, or maybe second to finally. The API work is currently hosted in the Spaces Wiki. The issue tracker for the work that we're currently doing, however, is on GitHub. There is a mailing list and periodic conference calls. We are looking for more increased participation, especially from international participants. We've intentionally tried to not build nationalistic assumptions into the API work, but we don't know if we did or didn't, and so additional help in vetting that would certainly be useful. And a link to the OR, it's another terribly named thing. That might be the theme for the APIs, is we can't name things correctly. But OR Match is the identity match software that I mentioned that is sort of in an alpha quality. And then finally, acknowledgments among many, many people who've been involved in this work over time. The core participants in the API work specifically and ongoing, we've got some names you might recognize: Keith Hazelton out of the University of Wisconsin at Madison, Chris Heiser out of University of Pennsylvania and the Grouper Project, and Jim Fox out of the University of Washington. So I believe that's it, and I guess we can do questions, and thank you.
Any questions? Yep.
Ben, just
She's coming with the...
Shell Wagner from Internet 2. Ben, I have to say that was the greatest glossary of terminology translation of how Cypher started and ended in tier that I've seen. I think the issue of the SCIM resolution that you've come to is really important for the broader community. Embracing different API standards is going to kill us in the long run. The added coding, the added time. Have you looked at doing other outreach efforts? Obviously, we're looking to incorporate all of this into tier, right, so that we have that standard. But have you looked at incorporating this with other identity projects outside of the U.S.? The VO issue is a huge one. And we're seeing, for example, the Magic project that's going on now with the Latin Americans, what's happening in Asia. So I'm just wondering if you've had further outreach and other interest in adoption of this modified SCIM approach.
Right. Outside of the U.S. specifically, that's part of the reason why we're here, is to kind of kick off that process. Within the U.S., in terms of the existing identity management projects, a number of the projects have been at the table kind of since the early days, so Grouper, for example. So yeah, we're aware of that as an issue, and I would say at the moment it's maybe a little bit unresolved.
So I think an opportunity there, we have the Trust and Identity Commission, the TIC group of Europe, who's here. I think it really would help us if we could find a way to extend to other regions, because it's like one hand clapping. If we can't get a global agreement on some of these APIs, there's still too much extra work we have to do.
Right. Thank you.
Thanks.
In the back.
Hello, Ben.
Uh-oh.
This is your SCIM working group chair speaking to you. From the end of the room, can I please get you to post that stuff that you made up, right? All of the analysis around the core schema work on the working group mailing list. Because we were struggling for a long while around, the usability of the core schema and where it went and what could go in it. And of course, most of the SCIM work has to do with consumer-facing cloud services, right? So it's a different kind of beast. I'm not at all surprised that you guys came up with a different core schema, but the rest of the internet needs to see it.
Yeah, I think we're definitely interested in doing that, and to be clear, we're actively tracking the SCIM work, albeit I think there are a few of us on the SCIM mailing list. I'm not sure how many are actively participating. But
I've only ever seen one from this community.
Keith Hazelton did a few messages a while ago around some
Chris, I think,
minor points. Yeah. But to the point that we're not as actively engaged in the SCIM community, I think yes, we should be more. I guess our concern to date has been, in addition to the usual just finding cycles to do things, that given that SCIM is heavily driven out of the commercial sector, I guess one of our questions is, how loud of a voice can we have in that working group?
Well, it's a very good meritocracy. You speak up and you get heard, right? Mm-hmm. So this is a problem. Leveling up a little bit. This is a problem in this community. We always come a little bit late to the table. Well, not always, but often, right? And I think it's great to have that ambition, right? But right now, all of the core documents are in the RC editor's queue. You gotta buy Heather dinner there up front if you want to have any kind of impact on skin at this point. So get these things published. Don't sit on them, right? I mean, the Internet 2 Wiki is a fine vehicle for collaboration, but it needs visibility outside this community, right? And it can't stay in these sort of closed rooms.
Yeah, I agree. And we get 2 thumbs up from the front row.
Any other questions?
So just prior to the last speaker, I'm going to go through the obligatory announcements. Posters are on display. The break is next, so this is your chance to go talk to the presenters of the posters because they'll be there. Demonstrations are scheduled at every break. Feedback. I think you've been asked a few times for your feedback. You'll see the big button, pink button on the main web page to do the feedback. The gala dinner is tonight. The buses depart from the pier side, right there, 7:15. The schedules were sent out in email. See the registration desk if you have any question. Watch the buses because when they return, they're coming back to different destinations. Tomorrow morning, we're going to start 30 minutes later, and as an encouragement for you to come on time, they're going to provide coffee and tea in the morning. Finally, there is a presidential car museum on the first floor for the Portuguese Presidential Car Museum that is free for participants, and you're invited to see it. So, with that, our last speaker today is on solving identity management problems with scientific e-collaborations. This is Bob Coles from the Center for Applied Cybersecurity Research at Indiana University.
Oh, come on, it actually says with sex. So you didn't want to say that, huh? So this is a report on research work done by the XM collaboration. They're the people that are involved in it. Vaughn Welsh, who some of you may know, is the principal investigator on it. This is a DOE research project. Our goal was to increase the productivity of DOE science by understanding identity management and the risk involved and projecting the direction of identity management in the 2020, the exascale timeframe. So what we've done is we've tried to understand the motivations and the barriers for identity management and how responsibility is shared between different people. We've tried to provide guidance for addressing those barriers and come up with a technical scheme for IDM sharing. And of course, these are available at the website there. For this talk, the vision and what I'm going to give away right here at the beginning is that the various technologies we have available can be combined into an integrated whole that provide a really interesting framework. So these technologies can be tailored so they're specific to different domains of research, and they will significantly lower the barriers for this long tail of science, for all of the collaborations that we see, the small collaborations that really don't have much in the way of IT expertise. The idea is to provide this not as an infrastructure, not as a platform, but as a service. So we have sex as a service, right? I made this up to make sure that the talk would be accepted, okay? I mean, how can you turn down a talk with a title that says Solving Identity Management Problems with Sex? Okay, so let's go back to virtual organization identity management. I mean, you know, like virtual organizations are sort of like interposed in between this identity provider and the resource provider. As David Wheeler is quoted as saying, you can solve any computer science problem with another level of indirection. And so the virtual organization concept basically provides this level of indirection. And the idea behind XM was that we've had 15 years of experience, at least, with various kinds of of solutions. So let's find out what was tried, what worked, what didn't work, and what are the directions that people are going. We performed over 20 interviews, both of virtual organizations and of resource providers, to find out what was going on there. What we found is that, of course, IDM is critical to science for various reasons that are listed here. However, the scientists don't understand how to talk to the security people about it, and the security people don't understand how to talk to the scientists about identity management. One thing that we came up with to try to resolve this was a way of discussing, okay, what is it involved here? So the model that we came up with for identity management data says we've got a user ID, some sort of contact information, and some sort of VO membership role type information. And then we use that over there in the functionality side for authentication, authorization, a whole list of things that are down there. So what we found was that as we talked to people about the direction they were going, there was more and more of a tendency for the resource providers to say, hey, we've got to get out of this business of identity management. We've got to lower the cost because the cost of dealing with all of these users is just too great. As we have collaborations that are large, this handling identity management doesn't scale. We need to centralize the management of VO policies at the VO. This is where the effort is most appropriate for it to happen. We don't want to have identity management data duplicated across different resource providers or different VOs. We want to improve the ease of use. Scientists that find they have to get a new user ID and password at every resource provider don't like that very much, nor do they like certificates. But we've got some contradictory demands, okay? So there's still a strong set of policies and current practices at a lot of the resource providers around identification, authorization, things like that of user communities. So these have been in place for 20 years, and we don't see any need to change them, right? Got that kind of attitude. The user communities, we have large-scale user communities with dynamic membership, people going in and out. They span multiple resource providers. They would like to have single sign-on, and they want to be able to manage the groups themselves. So we identified a number of barriers. There's, of course, historical inertia, aversion to risk, that's always a big one, and compliance and assurance requirements, and technology limitations. And we produced a paper. In a sense, it's sort of US-centric, and it's kind of aimed at some of the objections that the Department of Energy labs in the US had about how difficult it would be to adopt some sort of transitive trust model. This paper was in fact presented on Monday at the CLHS 15 conference. So it discusses issues in the US like deemed export, the unclassified forward visits and assignments, how clouds overcome technology limitations, and the shift to risk-based security to overcome some of the various inertia problems. Now, what we found is there still remain some drawbacks. So, for instance, IDPs may not want to release attributes. The users may not want these attributes released, at least not released very widely. There's also this long tail of science that's been talked about. So one of the interesting things we discovered is that, after the LHC experiments, and maybe Bell too, there's not really a lot of really big scientific experiments out there. What seems to be happening is that there'll be some agency that will fund some big instrument, say the Square Kilometer Array or LSST or something like that. So they'll fund that instrument and the operation to gather the data. And the data will be left somewhere, and then various research groups will then be invited to make proposals about how to analyze that data. But those research groups are all small, and they don't necessarily have a very good infrastructure to support them. They may not have any IT expertise, and certainly not identity management expertise. So we see this long tail of science is going to be a really big problem potentially in the future. There's also, at these small VOs, because they do not have much expertise in IT or in identity management, the resource providers don't particularly want to trust them. So what do you do with a problem like that? You want to have a transitive trust model. You want to have the work done by the VOs, except that you can't trust them. Well, problems don't exist in isolation. They're usually only one factor. So what do? You take the problem, you embed it in a larger problem, and you solve the larger one. Right? This is the opposite of what a lot of people do. Well, what you do is you take a problem and decompose it into parts you can solve, right? But if you can't solve a problem, you put it in a bigger problem. Doesn't that work? I don't know if any of you know M. Stuart Lynn. He was president of ICANN for a while. Before that, he was at University of California CIO. Before that, he was CIO at Cornell University, which is where I knew him. And this was his solution to problems. You embed them in a larger problem. Okay, so take the problem as being scientific collaborations need some way to access IT resources, but they don't want to know that that's what they're doing. So let's go back to this solution, this idea that we can provide indirection and use that to solve any computer science problem. So we've got a bunch of tools here. We've got this architecture that involves having a VO. Well, that can solve a privacy problem. Say the user registers with the VO and gives the VO attributes. All right, so that means we don't have to worry about the IDP releasing attributes. All the IDP has to do is verify the authentication. The VO, it handles the support and incident contacts and doesn't even pass attributes, and doesn't pass the attributes on to the resource provider. The VO takes care of all that. So assume that we can do that. We have the federated authentication, simplifies authentication for users, reduces cost and complexity for resource providers because now they don't have to do that. Now, the ID needs to be hard to obtain, at least from the resource provider point of view. Now, what do I mean by hard to obtain? If you use a social identifier and the resource provider says, we don't like you anymore, they want to be able to say, no, ixnay, we don't want this person anymore. If you're using a social identifier, it's very easy to create a new one and come back in again. So there's some resistance on the resource provider level of allowing social identifiers from that point of view. Of course, the other problem with social identifiers, which interestingly enough hasn't been mentioned, is that, for instance, with Facebook, if they decide they don't like something you said, they can cut you off since it's not your really resources. And so your identifier on one of these is not really yours, it's theirs. And it can disappear at any whim on the part of Google or Facebook. So those are some caveats associated with federated identification. There is a profile from the IETF, not from the IETF, IGTF, called IOTA, which basically allows for identifiers of the sort that you would use. It's sort of like if at a university level, if they're in the university's system of record, then those would be okay to be used. Portals. Portals are interesting. They provide some sort of uniform access. So usually collaborations have a standard set of tailored tools that they require, some wiki, source code control, analysis tools that are specific to the particular discipline, a way to submit jobs, and a consistent user interface in the federated authentication. So this is a way of now combining a bunch of these things all together. And of course, job factories allow the submission of analysis jobs and things like that. Jobs are often run under a single identifier, things like Panda and Dirac come to mind. In that case, the resource providers have to trust that the VO will resolve problems, or they're going to have to block access by the whole VO. And usually the threat of blocking a VO's access is enough to get the VO to actually do something about it. There is this thing called GLExec that can identify users under these circumstances, but the actual use of GLExec varies. And now we come to virtualization technologies. This provides a lot of increased isolation, security, recoverability. Hey, 50 years ago it was a good idea, and it still is. I did have to look up exactly how long ago that was. And then we have cloud computing models. So we have this on-demand provisioning resources, lots of resource available compared with the demands. The cloud handles disaster recovery. The cloud provides for security patching. It was a good idea 54 years ago, and it still is. That's when time sharing was done. So now we have a bunch of activities that are providing a number of these services at different levels. We have EGI Engage. Nectar is an effort in Australia to provide a bunch of specific frameworks for various disciplines. SciGap, HubZero, and Exceed Scientific Gateways in the US all provide these different sorts of sort of platform as a service or infrastructure as a service type things. And also the EGI Federated Cloud. So now, let's get back. What was the original problem we were trying to solve? We wanted to have transitive trust for identity management. We have this long tail of science that has no IT expertise. And we have to have the ability for the resource providers to trust these VOs to appropriately handle incident response. So the VOs need more support than just infrastructure or platform. So this is where the scientific e-collaborations come in. We combine these technologies that we've talked about into some sort of coherent, integrated whole. We tailor that with a discipline-specific tools, and it significantly lowers the barriers to entry. So think about basically, it's sort of like a VO or environment in a box where you can just instantiate it. This is sort of like the goal that Nectar has in Australia. They have a number of environments tailored for specific disciplines that you just sort of go to and say, okay, bring this up, and it fires up this whole set of services in a cloud-type environment. So these SECs are initiated with a framework tailored for specific disciplines. New members can register and provide their contact information, so they're voluntarily providing those specific attributes, whether or not the identity provider provides them or not. They authenticate with federated credentials, so there's no requirement for attribute release from the IDP. Okay, so the resource providers don't need to know who the user is because the access control rules are determined by the VO and passed along to the resource provider. This eliminates the need for the resource provider to maintain any IDM or to know specifically what the who the user is. In case of a compromise, at the identity provider, the resource providers are protected as soon as the VO cuts off the user. So now, one thing that's in addition to this environment is that we need to have some sort of operational capability. You need to have some sort of trusted entity that is actually operating this thing. So you can't, part of the, remember the problem was the resource providers weren't going to trust these small VOs. So you need to ensure the appropriate response for incident handling. And so this has to be provided as not as an infrastructure, not as a platform, but as a service. And the idea is that organizations like, say, EGI or OSG might be appropriate to sponsor or to actually operate these scientific e-collaborations. And that's sort of my proposal. Sex as a service. Any questions? This was at quite a different level than previous talks. No code.
Let's assume that one of these resource providers provides this VO infrastructure. Wouldn't that create a sort of vendor lock-in for the collaboration for that resource provider? What would happen if it wanted to use its if it wanted to use the other infrastructures as well? What if they want to use web cloud stuff, say Google to do their collaboration stuff as well?
I'm not sure I understand. So you're saying they would want to use multiple ones, or?
For example, yes. Why would they not want to use multiple ones? Why should they only want to use EGI, for example, and not also, the other one was called OGS, I think? Yeah.
Because they want to keep things simple. I mean, you can complicate things endlessly, or you can say, this is assuming that this is, again, we're trying to deal with this long tail of science. And yes, you can complicate things. This is this is conceptual at a high level in terms of where it is that we might want to go. Why not just, you could just fire this up under AWS and you'd have the whole thing. But if you wanted to use different infrastructures at the same time, yes, you could probably do it, but why? You would want to make it, you just want to make it more complicated? I don't know.
Well, I sort of see end users use different products all the day, every day. They switch from Google to Facebook for whatever they want to do. They switch between Dropbox and Box.net, etc.
Right. And yes, they do. However, they can't do that and keep it simple and have a simple interface also at the same time.
Okay.
Any other questions? All right, let's thank the speaker.
All right, with that, you all are free to go to the break a little bit early. Thank you.